Hi, Bobcats. In this video, we're going to take a look at how you name and write formulas for binary covalent compounds. So nomenclature just means all of those rules for writing names and writing formulas. Binary refers to two elements, right? So that prefix bi means two, and in this application, it means two elements. And covalent means a bond that's formed between a nonmetal plus a nonmetal. So we're going to be looking at the procedures for writing names and formulas for compounds that are composed of a metal and a nonmetal and a nonmetal. But before we can do that, I did want to take a quick look at how we write the symbols for elements. When we look at this list of elements, their names and their symbols, it looks like the pattern that's happening here is we're going to take the first letter of the element's name and use that as its symbol. I do want to point out that that has to be a capital. You cannot make it a lowercase h and be the symbol for hydrogen. It's got to be a capital H. Carbon's a capital C, fluorine is a capital F, oxygen's a capital O, and yttrium is a capital Y. Well, that's great. Looks like for these elements, we've found the pattern. First letter becomes a capital letter for the symbol. But wait, there's more. Let's take a look at some other elements. All of these elements start with the same first letter as the previous list. So we have the situation with 118 elements and only 26 letters in the alphabet that we will have multiple elements with the same first letter. So when we start looking at these, helium has a symbol He, calcium Ca. It's looking like we are taking the first two letters of the element's name and using those for the symbol. Francium, Fr, osmium, Os, all of that's looking great until we hit ytterbium. So ytterbium uses the first letter, Y, and then another letter that's there in the name, a B, but not the second letter. So generally speaking, a lot of the elements, their symbols are the first letter plus another letter from the element's name. Please note that the first letter has to be capital, and if there's a second letter, it's got to be lowercase, right? So first one uppercase, second one, if there is a second one, is lowercase. Great, looks like we're figuring this out. But what's going on here? There's no K in potassium. There's no A or G in silver. There's no W in tungsten. Where are these symbols coming from? Well, the answer is a language other than English. Some of our elements have symbols that are derived from the words in other languages. So for instance, tungsten, W, that comes from wolfram, which is the Swedish word for tungsten. Sodium symbol, Na, comes from Latin, natrium. The previous patterns still hold, though, that the first letter needs to be in uppercase and the second letter, if there is one, needs to be lowercase. So to kind of wrap that up, when we're going to write the formulas for just an element all by itself, most of the elements are monatomic, which means we just write them as one atom. We just write Fe for iron or C for carbon. In addition, there are 7 elements that are diatomic. Diatomic, let's break that down. Di and atomic. Di means 2. Atomic refers to atoms. So we're saying that these are 7 elements that when they naturally occur consist of atoms made up of 2 molecules. So we've got to write the subscript of 2 in the formulas. For instance, the oxygen that you are breathing right now is not just oxygen atoms, it is 2 atoms stuck together to make a molecule. So we're going to write the formula for oxygen as O2. I refer to these as the Bringelhoff elements. The way the elements are listed here: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. If you try to pronounce that, it comes out something like Brinkelhoff, right? So Brinkelhoff elements is what I'm going to call these. And also, some people memorize these based on their position in the periodic table. There are 7 of them. If you look at where they're located in the periodic table, they're in that upper right corner, making sort of the number 7 if you were to shade them in, plus hydrogen, because hydrogen's not part of that 7 in the periodic table, but it is part of the 7 that need a subscript of 2. So I would expect you, for writing an element, like if I ask you to write and balance a chemical equation and you have to write the formula for lead, I would expect you to just write Pb for lead. That's what we do for most of the elements, just the element symbol. The 7 Brinkelhoffs, like if I asked you to write the symbol for nitrogen in a reaction, you'd need to write N2. So the 7 Brinkelhoffs get a subscript of 2. And then, of course, everything I tell you in this course has exceptions. And so when we run into one of those other exceptions, like phosphorus is commonly P4 or sulfur is commonly S8, I'll tell you what it is in those cases. We'll just deal with those as they pop up. All right. In class, I would ask y'all to take a good hard look at this table and try to come up with the pattern to take a formula and write its name, or to take the names and write the formulas. For the purpose of brevity in this video, I'm going to ask you to just pause the video, see if you can figure that out. Once you figured it out, hit play again, and I'm going to go ahead and go on to the next slide. All right, so what is this process for writing names for covalent compounds? One of the things is that the names are going to contain numerical prefixes, and I'm going to write those in right over here. For 1, we're going to use the prefix mono. For 2, we're going to use the prefix di. 3 is tri. 4 is kind of a weird one. 4 is tetra. It's not quadra, it's tetra. 5 is penta. 6 hexa. 7 hepta. This one sometimes catches students. It starts with an H, not an S. 8 is octa. 9 is nona. That's kind of an unusual one as well. And then 10 is going to be deca. When we go to write the names from the formulas, the subscripts turn into these prefixes. If we're going the other way, if we're going from the formulas to the names, the subscripts, now I've confused myself. Anyway, depending on which direction you're going, subscripts turn into prefixes or prefixes turn into subscripts. If we're going to tackle the first element in the compound for writing its name, the first element, we're going to use the normal name. We don't make any changes to the element name, and the subscript corresponds to the prefix, except we omit mono. We do not use the mono prefix if there is only one atom of the first element. When we are tackling the second element in the compound, we're going to take the name of the element and put an IDE suffix on it. So at the end of the element name, we're just going to throw in IDE, and the subscript in the formula will correspond to the prefix, and with this one we use all of the numerical prefixes including mono. Let's look at some examples. Oh, sorry, I forgot we're going to look at the 2 exceptions. There are 2 compounds where IUPAC just said, you know what, everybody uses their common names, we're just going to make their common names their official names. These 2 compounds are water and ammonia. On a quiz or a test, if I give you H2O and ask for the name, The correct answer is water. Do not write dihydrogen monoxide. The correct answer is water. For NH3, ammonia, again, do not say nitrogen trihydride. We're going to go with ammonia. That is its official name. I wanted to just point out that on our polyatomic ion list, we also have NH4+, which is very, very similar. It's basically an ammonia molecule that's had an H+ ion stuck onto it. The name for this one is ammonium. Now we have some examples. Okay, IF, that's iodine and fluorine. The first element we name by its normal name. Because there's only one of them, and it's the first element, we do not put mono. For the second element, fluorine, we're going to change the ending to IDE. It'll become fluoride, and with the second element, we do use the mono prefix, and so this becomes iodine monofluoride. If we take a look at this next one, we've got iodine and fluorine. This time there are 3 fluorines. So again, the first one, there's only one. We don't use mono. We call it iodine with its normal name. But now instead of saying mono for the fluorides, we're going to say tri. There are 3 fluorides. That becomes trifluoride. For this next one, iodine pentafluoride, the prefixes tell us what the subscripts are. Since there's no prefix on iodine, there's just one of them. And then pentafluoride means that fluorine is the second element, and penta means 5, so it's IF5. For this next one, disulfur, that tells us we have 2 sulfurs, so S2. And then hept oxide, well, the element is oxygen, and hept means 7. Please note that here with oxygen, if the prefix ends with an A, we don't put that double vowel AO together. We don't say hepta oxide, it's just hept oxide. Then this last one, we've got 2 nonmetals, carbon and hydrogen, and so it looks like if we were to apply the rules for this, we would end up with tetracarbon, and then 10 hydrogens would be decoxide. Again, we wouldn't say decaoxide, it's just decoxide. We're going to drop that A. But if you write this on a quiz or a test, it is going to be marked wrong because this is a special case. This is one of the alkanes. If it's made up of just carbon and hydrogen and I'm asking you to name it, it's going to be an alkane. And we name the alkanes with an ANE ending and a prefix that tells us how many carbons there are. In this case, there are 4 carbons, and the prefix that goes with 4 is bute. So this is actually butane. Remember, those first 4 alkane prefixes are meth, eth, prop, and bute, and then starting with 5, they sound like numbers, pent. All right, one last slide. Just wanted to point out that yes, alkanes are covalent or molecular compounds because alkanes are made up of carbons and hydrogens in the pattern of CnH2n plus 2. Carbon and hydrogen are both nonmetals, and the family of covalent or molecular compounds are composed of nonmetals plus nonmetals, but when we go to do nomenclature on alkanes, don't use the covalent rules, use the alkane rules.